Hello, this is FTC Team 8645 Robotic Dogs, and this is our Control Award video. Our goal for the autonomous period was to achieve consistent high scores for each of the three starter stack options. Our autonomous routine can reliably score 2 wobble goals, up to 7 high goals, and park on the launch line with a maximum score of 119 points. All three of our autonomous routines end in similar locations, so the drivers always have a consistent starting point for teleop. For ring detection, we developed our own custom ring detector algorithm based on OpenCV. Using a webcam and our custom algorithm, our detector will locate rings anywhere within view of the camera with 100% accuracy. After identifying the starter stack in the frame, the detector will label it as 0, 1, or 4 rings by using a ratio of length versus height. Roadrunner is used for path planning in autonomous and position tracking in teleop. Our drivetrain has 3 odometry pod encoders, 2 on the sides and 1 in the rear. We use feedback from the odometers to create and follow complex spline paths to move to specific field locations during auto. We also use Roadrunner for position tracking during teleop to implement our auto aiming capability. Using positioning data from the odometry system, we first determine the field position and angle of the robot, which is our pose estimate. We then calculate the distance of the robot from the high goal and automatically adjust the shooting angle of the launcher and speed of the flywheels using custom mathematical functions. To develop these mathematical functions, we calculated ring trajectories and used that information as a base for creating lookup tables, which are native to Java. These calculations and extrapolations allow shooting from any location on the field. We have developed several driver-controlled enhancements for automating our launcher angle, hopper position, and flywheel speed. We have programmed the D-pad so that pressing up automatically adjusts for the high goal, and so that pressing down adjusts for the power shots. When the button is pressed in either direction, 3 things will happen. 1. The launcher adjusts its angle for the desired target by converting linear servo positions to the required target angle for the shooter. Second, the hopper moves to its precise position depending on the launcher angle. And 3, the launcher flywheels spool up to the required speed for the target by using feedback PID control on the shooter wheels to adjust by RPM versus the power ratio. Finally, we use a built-in motor encoders for positional control on the wobble goal arm. Using multiple buttons, we have presets for functions like grabbing wobble goals, holding goals in a stalled position, and placing the goals over the wall. Thank you for watching our Control Award video for the Ultimate Goal season.